Welcome to Easy Math TV. We're going to continue our discussion of compound interest using Excel or using a spreadsheet as a calculator, where this time we're going to be calculating present value of an account. Given that you want to reach a certain financial goal in the future, uh, what would you have to deposit now? So what would the present value need to be? You can see that it's already set up here, but I wanted to show you something pretty interesting that you can do that will just save you a lot of time. And this is based on our previous video. So if you have not seen it, make sure that you take a look at the previous video on the future value where, and I'm going to just click on that now. So this is what that sheet looks like. You can actually see that it looks almost exactly like the one that we just had. There's just a few minor changes that we're going to need to make. So when you're doing something like that, where you are essentially using the same kind of sheet that you had before, but just making some minor changes to it, we can basically copy that sheet onto a new sheet, onto a blank one. So I just want to show you how we do that. Down at the bottom, you'll see the name of that sheet that I've typed in. So like I've called it compound interest future values down here at the bottom. Okay. And I'm going to right click on that. And there's lots of different options that you can do with the entire sheet. We're going to copy it. So in this is my file name here. So it says time value of money.xlsx. That's the name of the file. And I'm going to put it at the end, and I'm creating a copy. All right. So make sure you click on the box, create a copy, and move it to the end because it's going to move it all the way to the right here. Now, I've already done that, so I'm not going to click OK, but if you're going to do it, definitely click OK. All right. So let's move over to there. So let's pretend that this is my copy of my future value sheet. All I needed to do was go up here and change the word future to present. So simple and compound interest, using the spreadsheet like a calculator, we're going to find the present value of an account when a lump sum deposit is made and interest is calculated over time with different compounding options. So all I had to do was change the word future to the word present. The other minor changes we're going to need to make over here in column B, instead of a capital P, that's going to be a capital A. And then those are our headings, by the way. So, and then over here in columns D through H, instead of capital A, those are going to be capital P. So I called the first one P1 and the second one P2, and then P3, P4, and P5. So just change all of those A's to P's. And based on the problem that was stated here, these numbers over here I've already updated. So we might as well just change those right now. So your interest rate is going to be 4%. The future value of our account is going to be $40,000. So 40,000. And then our time is 18. So go ahead and change those as well. So you're going to see different numbers here in these cells, but that's because you have not changed those formulas yet. So this is where we're only going to need to make some minor changes for the most part, except for the simple interest one. So look under simple interest for the moment. This is where we're going to have to type a new formula in. But it's the only time that we need to type a new formula. So under simple interest, the present value of an account is equals the future value, which is B4, divided by parenthesis 1 plus rate times time. So equals B4 divided by parenthesis 1 plus A4 times C4, close parenthesis. Okay? And now you should see that $23,255.81 number. Okay? To get all these other present value calculations made into the correct thing, all we need to do is change from future value formula to the present value formula in Excel. Everything else inside the parentheses is going to stay exactly the same. So that is pretty cool. We're not going to have to type a whole new series of things inside parentheses again. So like, at least not this time. So I wanted to just show you a couple of these, and then we will answer the question. So under the compounded once per year, you'll notice that this looks exactly like the future value formula, but instead of an FV, we're going to just replace the FV with PV, okay? The negative sign is still there, so equals negative PV parenthesis A4 comma C4, etc. But you don't have to touch that part, only the part in front. Instead of an FV, we're going to have a PV. Same thing over here under the quarterly compounded interest. Everything stays the same, except we're going to change the FV part in the front to a PV in the front. Everything else stayed exactly the same. So you should, if you fix that for all four of these, you should see numbers that are starting at 19,700 something and then slightly decreasing until we get at the end. If we had something compounded daily, we would only have to deposit $19,470.86. The differences are not that great, but there is a pretty significant difference between the quarterly compounded and the annually compounded difference. Like it's a $200 difference. So that, that can matter sometimes. All right, so the question asks, you know that you will need $40,000 for your child's education in 18 years. If your account earns 4% compounded quarterly, how much would you need to deposit now to reach your goal? So I know my mouse is kind of floating around a lot. So we're given that it's 4% compounded quarterly. So that means, where am I going to look? I'm going to look under my compounded 4 times per year column. And whatever number I see there, that is the answer to my question. So it's literally $19,539.84. That is the number that I need. And basically that's based on the present value formula in Excel. Like, subscribe, comment down below. Make sure you share these videos with as many people as you know that are taking a business math class or are taking a math class and they're doing some applied problems involving compound interest. Thank you very much.